Today we'll study equation of a cone in 3 dimensions. Now a cone, it is characterized by 3 attributes and the first one is vertex. So if we have to write equation of a cone, we must know vertex of this cone and it is say alpha, beta and gamma, and then there is a line which passes through this vertex and we call this line as generator, and this line, it also passes through a curve and this curve is called as guiding curve. So if we know vertex, guiding curve, and if we join vertex to the curve, we call it generator, and there are infinitely many generators of this cone. So all these lines, they are generators of this cone. Now equation of a cone in 3D, it is defined as ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d equals 0. Now what we'll do is, we'll try and prove equation of cone, it takes this form. So we already have this vertex, alpha, beta and gamma, and let us say equation of this guiding curve is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0, and it lies in xy plane, z equals 0. Now suppose direction ratios of the generator, they are L, M and N. Now once we have this point and L, M, N, we can write equation of this line. So equation of this line will be x minus alpha upon L equals y minus beta upon M equals z minus gamma upon N. Now we need to find this point A, and on A this z is 0. Now if we put z as 0, we'll get x minus alpha upon L equals y minus beta upon M, and it is equal to minus gamma upon N. So from here we can calculate this point x, and this point x will be alpha minus gamma into L by N, and y equals beta minus gamma into M by N. So coordinate of this point A will be written as alpha minus gamma L by N beta minus gamma M by N comma 0. Now this point A, it lies on this guiding curve, so it will satisfy its equation, so we'll put it in this equation. Now we can write this as A into alpha minus gamma L by N square plus 2h alpha minus gamma L by N beta minus gamma M by N plus B beta minus gamma M by N whole square plus 2g alpha minus gamma L by M plus 2f beta minus gamma M by N plus c equals 0. Now these elements, they'll vary. Now in order to find locus of these points x, y, z lying on these generators, what we need to do is, we need to eliminate L, M and N. Now from here what we can do is, we can write the value of L by N, and L by N is x minus alpha upon z minus gamma. So we can write L by N as x minus alpha upon z minus gamma, and we can also write M by N, and M by N is y minus beta upon z minus gamma. So now we can put the value of L by N and M by N to eliminate L, M and N. Now if we write alpha minus gamma L by N, so it will be alpha minus gamma, and this L by N will be x minus alpha upon z minus gamma. Now it will be z alpha minus gamma x upon z minus gamma. And in the same way we can write beta minus gamma, m by n is beta minus gamma, and m by n is y minus beta upon z minus gamma. So there will be beta z minus gamma y upon z minus gamma. Now if we put it here, we can write this equation as, now we simplify this equation, we'll get this equation in terms of x square, y square, z square. Then we'll also have yz, xz, xy, and then xyz plus constant term. So basically, standard equation of a cone will look like ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d equals 0. Now here the question is, find the equation of cone whose vertex is at origin and whose guiding curve is y square plus z square equals 16, and this is x equals 2. Now say direction ratios are L, M and N, then equation of this line will be x by L equals y by M equals z by N. Now this value of x is 2. Now if we put x as 2, we get y as 2 M by L and z as 2 N by L. Now this point will lie on this curve, so it will be 4 M by L square plus 4 N by L whole square, and it will be equal to 16. Now this 4 and 4 will cancel, so we'll get this 4 here. Now we need to eliminate element N. Now if we write M by L will be y by x and N by L will be simply z by x. Now we'll put these in this equation. So equation of this cone will be y by x square plus z by x square equals 4, or y square plus z square equals 4x square. This is the equation of cone we are looking for. Now it says, show that section of the cone by this plane z equals 1 is a hyperbola. Now if we take its intersection with this plane z equals 1, which means if we put z equals 1 in this equation, we can write this equation as 4x square minus y square equals 1, which is nothing but equation of a hyperbola. Which means basically this plane will intersect like this. So it will form a hyperbola. Now here the question is, find the equation to the cone with vertex at 1, 1, 0 and guiding curve is x square plus z square equals 4 and y equals 0. Now let us assume direction ratios of generator are L, M and N. Then we can write this equation as x minus 1 upon L equals y minus 1 upon M equals z minus 0 upon N. Now it passes through this point y equals 0. Now if we put y as 0, we'll get x as 1 minus L by M, and we'll get z as minus N by M. Now if we put the value of x and z in this equation, because we are taking this point which lies on this generator as well as on the guiding curve, we can write this equation as 1 minus L by M square plus minus N by M whole square, and it is equal to 4. Now we need to eliminate L, M and N. Now we know that L by M is x minus 1 upon y minus 1. So it will be 1 minus x minus 1 upon y minus 1 square, and N by M is z upon y minus 1 square, and it will be equal to 4. Now this is y minus x whole square plus z square, and it will be equal to 4 y minus 1 whole square. Now we simplify this, we'll get this as x square minus 3y square plus z square minus 2xy plus 8y minus 4 equals 0. And that is the equation of this required cone. Now here the question is, find the equation of a cone whose vertex is at -1, 1, 2 and guiding curve is 3x square minus y square equals 1 and z equals 0. So we have this guiding curve. Now let the direction ratios be L, M and N. Then equation of generator, we can write this as x plus 1 upon L equals y minus 1 upon M equals z minus 2 upon N. Now for the guiding curve, z is 0. Now if we put z as 0, then we can get x equals minus 1 minus 2 L by N, and we'll get y equals 1 minus 2 M by N. Now these x and y's, they lie on this curve, so it'll be 3, and this is 1 plus 2 L by N square, and minus, and y is 1 minus 2 M by N whole square, and it is equal to 1. Now we need to eliminate L, M and N. Now this L by N, it will be x plus 1 upon z minus 2, so it will be 3, and then 1 plus 2 x plus 1 upon z minus 2 square, and minus, this is 1 minus 2, and M by N is y minus 1 upon z minus 2 whole square, that is equal to 1. Now this is 3, and this is z minus 2 and 2x plus 2, so it will be z plus 2x whole square, and then minus, this is z minus 2 and minus 2y, so it will be z minus 2y whole square, and it will be equal to z minus 2 whole square, and this is the equation of required cone for which this guiding curve and vertex is given. So now we know how equation of a cone looks like. Now what about equation of a cone whose vertex is at origin? So if we have a cone whose vertex, it is at origin, and we'll prove that if vertex of this cone is at origin, then equation of a cone will be a homogeneous equation. So its equation will be ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy, and all of these, they won't be there in this equation. Now say this point, it is given by x, y and z, and we have another point on this line which is x dash, y dash and z dash. Now we know that direction ratios, they are proportional, so x minus 0 upon x dash minus 0 will be equal to y minus 0 upon y dash minus 0 and z minus 0 upon z dash minus 0, and say it is equal to some lambda. Now here we have lambda belongs to R, because as lambda varies, we'll have infinite points on the surface of this cone. Now this point A, we can write this as lambda x dash, lambda y dash and lambda z dash. Now this point A, it will lie on the cone. If we put the value of x, y and z, then we can write this equation as A lambda square x dash square plus B lambda square y dash square plus C lambda square z dash square plus 2f lambda square y dash z dash plus 2g lambda square z dash x dash plus 2h lambda square x dash y dash plus 2u lambda x dash plus 2v lambda y dash plus 2w lambda z dash and plus d equals 0. Now it is a quadratic equation in lambda. So we can write this equation as a x dash square plus b y dash square plus c z dash square plus 2f y dash z dash plus 2g z dash x dash plus 2h x dash y dash into lambda square, and then plus 2u x dash plus 2vy dash plus 2w z dash into lambda and plus d equals 0. Now it is a quadratic equation in lambda, but then lambda belongs to R. So we just not have two values, we have infinite values of lambda. And if in a quadratic equation we have infinite solutions, that means it becomes an identity, and it becomes an identity if A0, B0 and C 0. So from here we get this condition that ax dash square plus by dash square plus cz dash square plus 2f y dash z dash plus 2g z dash x dash plus 2h x dash y dash, it must be equal to 0. And also we'll get this condition that 2u x dash plus 2v y dash plus 2w z dash, it must be 0, and d equals 0. So we have this condition d equals 0. Now from the second equation we'll get equation of a plane, but then here we are looking for equation of a cone and not equation of plane. So here u must be 0, v must be 0, and w must be 0. So when we have uv and w and d 0, we are left with only this equation. So general equation of a cone will be given by ax square plus by square plus cz square plus 2fyz plus 2g zx plus 2hxy, and it will be equal to 0. Now this second result that we'll prove here is, if we have equation of a cone passing through origin, and which is ax square plus by square plus cz square plus 2hxy plus 2fyz plus 2g zx equals 0, and we have a generator whose direction ratios are L, M and N, then basically direction ratios of this generator, they'll satisfy this equation. So we'll prove that AL square plus BM square plus CN square plus 2H LM plus 2F MN plus 2G LN, and it will be equal to 0. And this is a very important result which we'll use in some questions. Now if we take a point on this generator, say x, y and z, then we can write this equation as x upon L, y upon M and z upon N, and let it be equal to lambda. We can write coordinate of this point as lambda L, lambda M and lambda N. Now this point, it lies on this cone, so it'll satisfy its equation. So we'll write A, and it'll be lambda square L square plus B, lambda square M square, C, lambda square N square plus 2H, lambda square LM plus 2F, lambda square MN plus 2G, lambda square Ln, and it will be equal to 0. Now we'll take this lambda square common, and then we'll get AL square plus BM square plus CN square plus 2H LM plus 2F MN plus 2G Ln, and it must be equal to 0. So direction ratios of any generator, they'll satisfy equation of this cone. So if we have equation of a cone as sum f x y z equals 0 and direction ratios of any generator are L, M and N, then we can simply say f L, M and N will be equal to 0, and we can also use the result other way. If L, M, N, they are direction ratios of generator of a cone and they satisfy this function f L, M, N equals 0, then equation of cone is f x, y, z equals 0. Now here the question is, prove that the line x upon L equals y upon n equals z upon n, where L square plus 2m square minus 3n square equals 0 is a generator for the cone x square plus 2y square minus 3z square equals 0. Now this is equation of a cone passing through vertex 0, 0, 0, and origin lies on this generator. Now we know that if direction ratios of generator L, M and N, they satisfy some function phi, then equation of this cone is phi x, y, z equals 0. Now if we replace L with x, M with y and N with z, equation of this cone will be x square plus 2y square minus 3z square equals 0, and which is what we need to prove in this question. Now here the question is, show that this line is generator of the cone. Now since this curve is homogeneous and this line, it also passes through origin. So point on this line, it satisfies this equation. Now we look at direction ratios of this line. Direction ratios are 2, -1 and 3. Now this line will be generator of this cone if direction ratios they satisfy this equation. So we need to check if L square plus M square plus N square plus 4LM minus Ln, it is equal to 0. Now we'll put this value. This is 4 plus 1 plus 9 and this is -8 minus 6. Now this is 14 minus 14 and which is 0. That means this line, it indeed is generator of this cone. Now we'll prove our third result, and which is equation of a cone whose vertex is at origin and which passes through 3 coordinate axes. It is given by fyz plus gzx plus hxy equals 0. So this is equation of a cone with vertex at origin and which passes through all the 3 coordinate axes. So all the 3 coordinate axes, they'll be generators of this cone. Now we already know that equation of a cone with vertex at origin, it is given by ax square plus by square plus cz square plus 2hxy plus 2fyz plus 2g zx equals 0. Now one of the generator of this cone is x-axis and direction ratios of x-axis, they are 1, 0, 0, and we have proved that direction ratios of any generator, they'll satisfy this equation. So we'll put this value. So if we put L, M and N as 1, 0, 0, then we'll get A equals 0. For y-axis, direction ratios are 0, 1, 0. From there we'll get B equals 0, and for z-axis it'll be 0, 0, 1, and we'll get C equals 0. Now if we put A, B and C as 0, then we'll get equation of this cone as 2hxy plus 2fyz plus 2g zx equals 0. We'll cancel this 2. So this equation will be hxy plus fyz plus g zx equals 0. So this is equation of a cone with vertex at origin and passing through all the 3 coordinate axes. Find the equation of a cone passing through coordinate axis and having these lines as generators. Now we know that equation of cone passing through coordinate axis, it is given by fyz plus gzx plus hxy equals 0. Now direction ratios of these first generator, they are 1, -2 and 3, and we know that direction ratios, they satisfy this equation. So we'll get this as -6f plus 3g and -2h, and it'll be equal to 0. Now direction ratios of this second line, they are 3, -1 and -1. So they are L, M and N. Now they'll again satisfy this equation. F, now z-axis M into N. So it'll be this F. Now Z into X. Z into X is this -3. So it'll be -3g, and then X into Y is -3h, and it'll be equal to 0. Now we can write this as F, G and H. Now this is B1, B2. So it'll be 3, -3 and C1, C2. So this is -2, -3. Now this is -2, -3. This is -6, 1, -6, 1 and 3 and -3. So it'll be -9, -6. So F upon -15. G is -2, -18, -20, and H is 18 -3, 15. So these F, G and H, they are proportional to -15, -20 and 15. Now we take them as some lambda, then we can write this F as -15 lambda, G as -20 lambda, and H as some 15 lambda. And if we put them in this equation, we can actually take minus 5 lambda common. So if we take minus 5 lambda common, so there'll be 3yz plus 4zx minus 3xy equals 0. So equation of this cone will be 3yz plus 4zx minus 3xy equals 0. Now we'll come to a right circular cone. Now basically a right circular cone is a surface generated by a straight line passing through a fixed point, which is vertex, say alpha, beta and gamma, making a constant angle theta with a fixed straight line passing through a given point. So this fixed straight line, and we call this line as axis of a cone. So we'll be given vertex alpha, beta, gamma, we'll be given this half angle theta, and then we'll be given this fixed straight line, which is your axis of cone. Now we need to write equation of a right circular cone. Now for this, what we'll do is we'll take up a general point on the surface, and we'll take this point as x, y and z, and say this point is A. Now we can write direction ratios of VA. Direction ratios of VA are x minus alpha, y minus beta and z minus gamma, and we'll also be given equation of the axis or direction ratios of the axis. And suppose direction ratios of the axis are L, M and N. Now once we have direction ratios of two lines, we can find angle between them, and it'll be given by cos theta, and it'll be equal to A1, A2. So it'll be L x minus alpha plus M y minus beta and plus N z minus gamma upon under root of L square plus M square plus N square into under root of x minus alpha square, y minus beta square and z minus gamma square. And this is the equation of a right circular cone. So if we square it, we can write this as cos square theta into L square plus M square plus N square into x minus alpha square, y minus beta square and z minus gamma square, and here will be L x minus alpha plus M y minus beta plus N z minus gamma whole square, and this is the equation we are looking for. Now the question is, find the equation of a right circular cone with vertex at origin and axis in the direction of 2, minus 4 and 3, and this semi-vertical angle as 30 degrees. Now let us choose any point, say P, X, Y, Z on the surface of this cone. Now direction ratios of this line, there are X, Y and Z, and here direction ratios are 2, minus 4 and 3, and angle between them is 30 degrees. So we can write cos 30 as 2x minus 4y plus 3z upon, now this is under root of x square plus y square plus z square, and then into, now this is 16 plus 9, 25, 25 plus 2 is, 25 plus 4 is root 29, and is equal to cos 30, and cos 30 is under root 3 by 2. Now we square it, we can write this as 4 into 2x minus 4y plus 3z whole square, and it will be equal to 29 into 3 into x square plus y square plus z square. So it will be this 4 into 2x minus 4y plus 3z whole square, and 29 into 3 is 87 x square plus y square plus z square, and that is the equation of this right circular cone. Now the question is, find the equation of a right circular cone whose vertex is at 2, minus 3 and 5, and which passes through this point, which is 1, minus 2 and 3, and whose axis makes equal angle with coordinate axis. So if it makes equal angles with coordinate axis, then alpha equals beta equals gamma. That means direction cosines, they'll be same, L equals M equals N. Now L square plus M square plus N square is 1. That means value of L, M and N is either plus 1 by root 3 or minus 1 by root 3. So from here we'll get direction ratios of this axis, and they are 1, 1 and 1. Now first we'll find this half angle using dot product. Now direction ratios of this line will be 1, minus 1 and 2. Then cos theta will be 1 minus 1 plus 2 upon under root 6, and this is root 3. So it will be simply under root 2 by 3. So this half angle is cos inverse root 2 by 3. Now we take any general point, say x, y and z, then we can write cos theta, which is under root 2 by 3 as dot product between this vector, which is x minus 2, y plus 3 and z minus 5, and then this is 1, 1 and 1. So it will be plus 1 and plus 1 divided by, now this is root 3 and this is x minus 2 square plus y minus 3 square plus z minus 5 square. Now it's root 3 and root 3 will cancel. Now we square it, we can write 2 into x minus 2 square plus y plus 3 square, because we have plus here, y plus 3 square plus z minus 5 square, and it will be equal to 3 into, and this is x plus y plus z, and here will be minus 4 whole square. And this is the equation of this right circular cone. Now the question is, obtain the equation of right circular cone which is generated by revolving the line whose equations are 3x minus y plus z equals 0 and 5x plus y plus 3z plus 1 equals 0 about y-axis. So we are talking about this y-axis. Now on y-axis, x and z, they are 0. Now if we put x and z at 0, we'll get y as minus 1. So this vertex of this cone will be 0, minus 1 and 0. And axis of this cone will be along y-axis. So direction ratios are 0, 1 and 0. Now we need to find direction ratios of this generator. And since this line, it is line of intersection of two planes, we can find its direction ratios using cross product. So this is I, j and k. Now here it is 3, minus 1, 1, and this is 5, 1 and 3. Now this is minus 3, minus 1, so there will be minus 4i. Now this is 9 minus 5, minus 4j, and here will be 3 plus 5, 8, plus 8k. So direction ratios of this line, they are 1, 1 and minus 2. Now once we have direction ratios, we can find this half angle theta. Now cos theta will be 1 upon under root of, now this is root 6 and this is 1. Half angle is cos inverse 1 by root 6. Now we take any general angle which is x, y and z, we can write cos theta, which is 1 by root 6 will be 0 into x minus 0 plus 1 into y plus 1 plus 0 into z minus 0 upon, now this is 1 and this is under root of x square plus y plus 1 whole square and plus z square. Now we square it, we can write x square plus y plus 1 whole square plus z square will be equal to 6 y plus 1 whole square, and that is the answer to this question. Now there'll be some questions where we need to find equation of a cone with vertex at origin and passing through the guiding curve as intersection of the curves given by f x y z equals 0 and g x y z equals 0. Now what we'll do is, using these two equations, we'll make the curve homogeneous, and this homogeneous equation in second degree will represent equation of this cone. Now say for example, find the equation of a cone with vertex at origin whose guiding curve is given by x square plus y square plus z square minus 2x plus 2y plus 4z minus 3 and x square plus y square plus z square plus 2x plus 4y plus 6z minus 11 equals 0. Now in order to make the curve homogeneous, we have two options. Now one is, we can directly subtract this first equation from the second equation. Then we can write 4x plus 2y plus 2z minus 8 equals 0, or that is 2x plus y plus z equals 4, and we can write this as 2x plus y plus z upon 4, and it is equal to 1. Now using this, we can make either of these two curves homogeneous. So we can write this equation as x square plus y square plus z square. Here we already have degree 2, and then plus minus 2x plus 2y plus 4z, and here we need to increase this degree by 1. So it will be multiplied with 1, and then minus 3 into 1 square equals 0. Now we can write this as x square plus y square plus z square minus 2x plus 2y plus 4z into this 1, and this 1 is 2x plus y plus z upon 4, and minus 3, and here will be 2x plus y plus z upon 4 whole square, and it will be equal to 0. And if we simplify this equation, we'll get this result as 12x square minus 21y square minus 29z square minus 18yz minus 12zx plus 4xy equals 0, which is the required equation of this cone. Now another way to solve this question is by taking a parameter t to make the curve homogeneous. So we can write this first equation as x square plus y square plus z square minus 2xt plus 2yt plus 4zt minus 3t square equals 0, and then we have x square plus y square plus z square plus 2xt plus 4yt plus 6zt minus 11 t square equals 0. Now again we'll subtract this first from second, so we'll get 4xt plus 2yt plus 2zt minus 8 t square equals 0. So from here we'll get this t as 2x plus y plus z upon 4, and if we put the value of t here, we'll end up getting this same equation. So that is second method of solving such questions. Now here the question is, find the equation of a cone with vertex at origin and containing these two curves. Now here what we need to do is we just need to make this curve homogeneous, and it will be given by ax square plus by square, and this is 2z, and we'll multiply it with this 1, and we'll get this one from lx plus my plus nz upon p equals 1. So this equation will be ax square plus by square plus 2z, that is lx plus my plus nz upon p, and this is the equation of required cone. Now here the question is, prove that this equation represents a cone and find its vertex. Now what we'll do is, we'll assume it is some function f, and then we'll find del f upon del x, and we'll put it equals to 0. We'll find del f upon del y, we'll put it equals to 0, and then del f upon del z, and we'll put it equals to 0, and we'll solve these three equations to find vertex of this cone. Now we differentiate it with respect to x, we'll get this as 8x plus 2y plus 12 equals 0, which is 4x plus y plus 6 equals 0. Now we differentiate it with respect to y, we'll get minus 2y plus 2x minus 3z minus 11 equals 0. So it will be 2x minus 2y minus 3z minus 11 equals 0. And then finally we differentiate this equation with respect to z, we'll get this as 4z minus 3y plus 6 equals 0. So there will be minus 3y plus 4z plus 6 equals 0. Now from this second and third equation, we'll eliminate this y first. So we'll multiply it with 4, multiply this with 3, and then we'll add them. We'll get this as 8x. Now here it is 8y and minus 9y. So there'll be minus 17y. Now this z will cancel. Now this is minus 44 and 18, which is minus 26 equals 0. And here we'll multiply it with 2. We'll get 8x plus 2y plus 12 equals 0. Now we subtract this first from second. 8 and 8 will cancel. So we'll get 19y plus 38 equals 0. So value of y is minus 2. Now if we put y as minus 2, we'll get x as minus 1. And if we put y as minus 2 in this, we'll get z as minus 3. Vertex of this cone is at minus 1, minus 2 and minus 3. And actually we have not verified this is the equation of a cone. And for this what we'll do is, we'll make this curve homogeneous, which is say 4x square minus y square plus 2z square plus 2xy minus 3yz plus 12xt minus 11yt plus 6zt plus 4t square equals 0. And we'll find del f upon del t and we'll put it equals to 0. Now we differentiate this with respect to t. We'll get 12x minus 11y plus 6z plus 8t equals 0. Now we put the value of x, y and z. We'll get minus 12 plus 22 minus 18 plus 8t equals 0. Now this is 8t equals 8 and value of t is 1. And when we have value of t as 1, we'll get the same equation. So this equation, it does represent equation of a cone. Now there will be questions on equation of enveloping cone of sphere x square plus y square plus z square equals a square from the vertex alpha, beta and gamma. So we have this sphere whose equation is x square plus y square plus z square equals a square. And then we have this cone which envelopes this sphere. And vertex of this cone is at alpha, beta and gamma. Now what we'll do is, we'll take a point on this line, say this point P, and suppose direction ratios are L, M and N. We can write equation of this line as x minus alpha by L, y minus beta by N, and z minus gamma by N, and say it is equal to some lambda. Then we can write coordinate of this point P as alpha plus L lambda, beta plus M lambda and gamma plus N lambda. Now this point P, it lies on this sphere, so it satisfies its equation. So we can write alpha plus L lambda square, beta plus M lambda square plus gamma plus N lambda square, and it is equal to A square. Now we simplify this, we can write this equation as L square plus M square plus N square into lambda square plus 2L alpha plus 2M beta plus 2N gamma into lambda and plus alpha square plus beta square plus gamma square minus A square. It must be equal to 0. Now since this line will be tangent to this sphere, it will have only one point of intersection. So this quadratic equation should have only one real root. That means value of d, it must be equal to 0. Now we put b square equals 4ac. We'll get 4 L alpha plus M beta plus N gamma whole square, and it will be equal to 4 ac. So it will be 4 L square plus M square plus N square into alpha square plus beta square plus gamma square minus A square. Now this 4 and 4 will cancel. Now we need to eliminate L, M and N, and what we can also do is we can multiply everything with lambda. So we can write lambda L alpha, lambda M beta, lambda N gamma square. So it is lambda square here, and here we can write lambda L square, lambda M square plus lambda N square, and this is alpha square plus beta square plus gamma square minus a square. Now, lambda L, it is nothing but x minus alpha. So we can write this as alpha into x minus alpha plus beta into y minus beta and plus gamma into z minus gamma whole square, and it'll be equal to x minus alpha square, y minus beta square and z minus gamma whole square, and it'll be equal to alpha square plus beta square plus gamma square minus a square. And if we simplify this, it'll simplify to alpha x plus beta y plus gamma z minus a square whole square, and it'll be equal to x square plus y square plus z square minus a square, and it'll be alpha square plus beta square plus gamma square minus a square. And if you are familiar with concepts in conic sections, then we know that equation of pair of tangents is given by S1 equals t square, and this form itself is S1 and this is t square. So we can also solve this question directly by using this concept of S1 equals t square. We have already discussed how to find S1 and t in one of the previous videos in conic sections. So I'll put the link to that video in the description below. Now the question is, find the enveloping cone of this sphere with vertex at 1, 1, 1. Now if we find t equals 0, t equals 0 will be 1x plus 1y, 1z minus x plus 1 plus 2 z plus 1 and minus 1 equals 0. So this equation will be, now this x and x will cancel. We'll get this as y plus 3z equals 0. So now we have RT and S is basically the same equation. So this S is x square plus y square plus z square minus 2x plus 4z minus 1, and then S1 is this value. If we put x, y and z in this equation, so we'll get 1 plus 1 plus 1 minus 2 plus 4 minus 1, and there will be 4. So equation of this enveloping cone will be S1 equals t square. Now S is x square plus y square plus z square minus 2x plus 4z minus 1 into 4, and it will be equal to y plus 3z whole square. Now this is 4x square plus 3y square minus 5z square, and then it will be minus 6yz minus 8x plus 16z minus 4 equals 0. And that is the equation of enveloping cone of this sphere.